So this is our task for video assignment PHY110 for Chapter 7, which is linear momentum. So please do subscribe and like this video and also share the love. Thank you.
Okay, today we will learn about Chapter 7, linear momentum. So first of all, there are two types of momentum in the momentum and impulse. So the first of all is linear momentum. So linear momentum equal to P equal to mv. P equal to linear momentum mass times with velocity. So the second one is impulse and impulsive force. So this is for impulse. This is for impulsive force. So impulse equal to Ft equal to m bracket v minus u bracket. This is mass, final velocity, initial. So this is for impulsive force. F equal to m bracket v minus u divided by t. So the definition of linear momentum is the product of mass, defined as the product of mass and velocity. So the unit of the linear momentum equal to kg meter per second. So the second one, impulse and impulsive force. The unit for impulse is Newton per second. The second one for the impulsive force is Newton. So the second one is we will go and learn about conservation of momentum. So first of all, we will know about the law of conservation of momentum. So the law states that the total momentum before equal to the total momentum after, as long as no net force is applied to the object. So the equation is m1 u1. This is for object 1. So this is for object 2. So u is for initial velocity. So this is for final velocity. So after that we will learn about elastic collision and elastic collision. So in elastic collision, this is of m1, this is m2. So first of all, it will go to the right and this m2 will go to the left. After it collide, it undergo in elastic collision. So m1 will go to the opposite direction and m2 also will go to the another direction. So it will separate. So the equation is at first 1 over 2 m1 u1 square plus 1 over 2 m2 u2 square equal to 1 over 2 m1 v1 square plus 1 over 2 m2 v2 square. So we can simplify 1 over 2, 1 over 2, 1 over 2, and the last equation we get is m1 u1 square plus m2 u2 square equal to m1 v1 square plus m2 v2 square. So it's related with the law of conservation of momentum, which is the total momentum before equal to total momentum after. Okay, after that we will learn about inelastic collision. So in elastic collision, different with elastic collision. So first of all, this object collide with the m2. This is m2, this is m1. So after it's it go to the direction and it will go to the left. So after that, after it's undergo in elastic collision, the object will be together. So the mass will be plus this and we get m total. So the equation of the inelastic collision is 1 over 2 m1 u1 square plus 1 over 2 m2 u2 square equal to 1 over 2 m1 v1 plus 1 over 2 m2 v2 square plus energy loss. So we can simplify 1 over 2, 1 over 2, 1 over 2, 1 over 2. So the mass total m1 u1 square plus m2 u2 square equal to, so the mass is equal, so we can factorize to be like this, v2 square minus v1 square v2 square plus energy loss. So the inelastic collision is different with elastic collision because after the collision it will stick together of the two objects.
Okay, first the question about the linear momentum topic. First question is, a ball with mass 2 kg with velocity 20 meter per second. After being kicked, it moved with velocity 50 meter per second in the opposite direction. Find the impulse caused by the kick. So first we need to collect the information given, which is the information given is mass equal to 2 kg and also the velocity 20 meter per second, initial velocity u equal to 20 meter per second, and also the velocity, which is the final velocity, equal to 50 meter per second. So find the impulse caused by the kick. Okay, we use the equation Ft, which is impulse, equal to mass bracket final velocity minus initial velocity. So the information we can substitute the information given into this equation. So first, m equal to 2 kg, bracket v will be negative 50 because of the opposite direction. So negative 50 minus 20 meter per second. So the answer is negative 140 kilogram meter per second. So this is the answer.
Okay, the second question is, a skater with mass 50 kg is skating at 6 meter per second collides with another skater with mass 30 kg and moving with 3 meter per second. Both of them moving in the same direction and final velocity given is 2.8 meter per second. Find energy loss. So here both of them moving in the same direction. It showed that it was in elastic collisions. So the questions want we to find the energy loss. First, we identify the information that was given. 50 kilogram is equal to m1 and 6 meter per second is u1. Next, 30 kilogram equal to m2 and 3 meter per second is u2. So because of we want to find the energy loss, we use the equations of inelastic collisions. 1 plus 1/2 m2 u2 square equal 1/2 m1 v1 plus m1/2 m2 v2 square plus energy loss. Okay, so we substitute the information that was given. 1/2 multiply with 50 6 square plus 1/2 30 3 square equal to 1/2 50 2.8 square plus 1/2 30 2.8 square plus energy loss. So we want to find the energy loss. After we calculate this, we get 36135 equal to 313.6 plus energy loss. So we want to find the energy loss. This we minus with this. So the answer is 35821.4 joule. So this is the answer.
Okay, next we move to the third question. Okay, a body mass 20 kg is moving with a velocity of 6 meter per second, having a head-on collision with another body of mass 8 kg that is moving on the opposite direction with a velocity of 10 meter per second. The first body has been stopped by the collision. Find the velocity for the second body. So we can identify this is a linear momentum. So which is the momentum before equal to the momentum after. So we need to collect the information given, which is the first body, mass first body M1 equal to 20 kg. So the U1, which is the initial, equal to 6 meter per second, and the first body has been stopped by the collision, which is the V1, the final velocity 0 meter per second. And also we can detect that, we can identify that the M2 was given, which is 8 kilogram. M2 equal to 8 kilogram. U2, which is the initial velocity for the second body is 10 meter per second, but we need to put the negative sign because of the opposite direction. So negative 10 meter per second, and we want to find the velocity for the second baby, for the second body, because the information was not given, which is we want to find the velocity. So we need to use the equation M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So we want to find the V2, which is the second body of final velocity. So we can substitute the information given, which is M1 equal to 20, U1 equal to 6 plus M2 8, U2 negative 10 equal to M1 to 20, and V1 equal to 0 because of its stop, plus M2 8, and we want to find the VU. So after we calculate it, we got the 8 V2 equal to 40. So V2 equal to 5 meter per second. So this is the final answer.
The last question is, mass of 4 kg is moving with a velocity of 4 meter per second, hitting a mass of 5 kg that is moving with the velocity 7 meter per second in the opposite directions. After the collisions, both masses stick together. Find the velocity for each mass. So first, we write the information that was given. 4 kg is mass 1. 4 meter per second is U. Next, 5 kg, which is M2, and 7 meter per second is is u2. The equation that we use to find the velocity is m1 u1 plus m2 u2 equal to m1 plus m2 v. So we want to find the velocity. We substitute the information that was given into the equations. So 4 multiply with 4 plus 5, the initial is negative 7 because of the opposite directions, equal to 4 plus 5 velocity. So after we calculate this, we get 16 minus with 35 equal to 9v. Negative 19 equal to 9v. So the velocity is negative 19, 9. Velocity is negative 2.1 meter per second. So this is the answer for this question.